All right, everyone, what we're going to do today is talk about things that can be simplified or simpler ways of writing mathematical expressions. So, for example, if you see something that says y plus y plus y plus y, what you see is the same thing being added over and over again, 4 times specifically. Think of it as 3 plus 3 plus 3 plus 3. Now, a long time ago, we learned that if we saw 3 plus 3 plus 3 plus 3, we could write that as 4 groups of 3 or 4 times 3. And it's true with variables also. That's what this y is, a variable. It could stand for any number. And whatever that number is, we have 4 of them. And we would write that like this. The 4 is called the coefficient. It tells us how many times to add the number, or how many times we'd multiply it, right? That means a multiplication. We're going to multiply by 4 because we're adding it 4 times. So y plus y plus y plus y can be written as 4y, or 4 times y. All right, let's take a look at another one. Oh, that's the wrong button. I was afraid of that. Let's peek over here. Let's take a look at this. Right? What happens when you see something like this, y plus 3 plus y plus 3 plus y plus 3? Well, we're adding 2 different kinds of terms here. We're adding y's and 3's. But we're very lucky. Addition has something called the commutative property. That means it doesn't really matter what order we add things in. We can rearrange them to add them so that they're easier. Like I might write this as y plus y plus y, because there's actually 3 y's in this sum. Right here, this is the sum of 6 terms. And I could also add a 3 and a 3 and a 3, because there were 3 3's here. I just rearranged them using the commutative property. And now it's easier to see that this would be 3y, right? Because we're adding y 3 times, or multiplying by 3, so our coefficient is 3. And we're going to use the word and here to show that this is addition. And there are these other things. There's 3 3's, so I can write this as 3 times 3. When you're multiplying numbers, you still have to use a multiplication symbol so we don't think it's 33. Now, there's an even simpler way we could write this. 3y, well, we can't actually solve that or evaluate it any farther because we don't know what y is. Y could stand for any number. But we do know what 3 times 3 is. That's 9. So here we have the sum of just 2 terms. 9 is a term, and 3y is a term. Right? We went from having 6 terms, 1, 2, 3, 4, 5, 6, to just having 2 terms. That's much simpler. All right, let's take a look at some of these in an application. Right? How can we use this? Let's take a look at the square. Take a look at the square. Let's just go ahead and say, for the sake of argument here, that x equals 10, right? X equals 10. Now, we could change it to some other number, but let's call it 10. And then we can kind of see that this is 2 groups of 10 plus 4, right? That would be 24. So just to make ourselves feel comfortable, if I was going to find the perimeter of this rectangle, I could write one side is 2x, or 2 times 10, plus 4. And I could say another side, the perimeter is the sum of all the sides, 2x plus 4. I could say another side, that's 2 sides. Another side would be another 2x plus 4. I'm going to run out of room here. And another side would be plus 2x plus 4. I'm putting them in parentheses so we can see that that's its own term. That's one side, that's another side, that's another side, and that's another side. Now, remember, our goal here is to write things simpler. So here it looks like I'm adding the same thing 4 times. So I'm just going to use a coefficient of 4 to show that I'm multiplying this 4 times. And what is it that I'm multiplying? Well, it's the sides, 4 sides. That's 2x plus 4. Right? So there we've solved that. Now, we could check it, right? If I told you that each side was 24, I could write, 24. Let me try that again, right? Just so we can kind of see what we're doing here is making sense. I could write 20, that's 2 10s, and a 4. Or I could write that 24. But let's just write it like this, 20 and 4, 20 and 4, 20 and 4. Right? So we have 4 of them. Okay, so we could add them up like that. What I'd like to show you next is another way that we could write this, right? And we're going to use what's called the distributive property. I could say that I have 4 groups of 2x, right? You can kind of see them right here. There's one group of 2x, there's another group of 2x, there's another group of 2x, and there's a fourth one. So that gives me 8 x's. Right? That's another way of writing that. 4 groups of 2x. And I can also say that I have 4 groups of 4. Right? So I'm going to say and I have 4 groups of 4. That's 16. So let's kind of reference these two things so I can see that they are the same. I said 4 groups of 2x would be 8 x's. Here we have 2 groups of 10. That's our 2x right there. That's a 2x. And if I had 4 of them, that would be 80, or 8 times 10. That's 8x. So 8x's is 80, right? I said I had 4 groups of 4, and that makes 16. And I can see them here. There's 1 group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4. And that makes 16. So that's our 8x, or 8 times 10, and that's our 16. We can also see it over in the square real quick. Let's just go back and look at this. There's 2x's plus 2x's plus 2 more x's plus 2 more x's. That's 8 x's. And here I see 1 4, another 4, another 4, and there's the fourth 4. That's 4 4s. That's 16. So I want you to see that these two things are equivalent. I guess I'll rewrite this over here with an equal sign, right? 4 groups of 2x plus 4 is the same as 8 x's plus 16. They're equal. All right, let's try another one with the distributive property. Now this that may have been too much information, but let's just take a look at it at another example. This one's kind of small. Let's see if we can zoom in on it. So here's a triangle, right? It says that we have, I'm just going to write it as a factor here. It says we have 3 groups of 2x plus 3. Right, we have 3 of these things. So I could write 2x plus 3 plus 2x plus 3 plus 2x plus 3, but it's just simpler to use the coefficient. 3 times 2x plus 3. Now, there's another way we could look at this. Again, I'm going to use the distributive property. I have 3 of these, right? Let me see if I can see them here. There's 1, 2, 3, right? How many x's is that altogether? 3 times 2 is 6x. And I have 3 of these. You can see them right here. 1, 2, 3. 3 3s is 9. So what we can say is that 3 groups of 2x plus 3 equals 6x plus 9. We're just using the distributive property to write it in a different form. Okay? Actually, I'll just erase this one here. Now, if you're ever confused by this, just take the time to write it out. Right? You could write it out. 2x. Sorry about that. 2x plus 3 plus 2x plus 3 plus 2x plus 3. Those are the 3 sides. That's one side, another side, another side. You could use the commutative property to rearrange them. Let's put the 2x's together. 2x plus 2x plus 2x plus 3 plus 3 plus 3. And then you can see if I add all these together, that would be 6x's. And if I add all these together, I would get 9. 3 plus 3 plus 3 is 9. Okay, so that's another way you could do it. But remember, multiplication is supposed to make your life easier. All right. That's a good introduction. Actually, that covers a whole bunch of stuff. I hope that helps.